Hello, I'm Songmin Lee and I will be presenting this video. Our Team 6, focuses on IoT and lightweight solutions. We will be talking about IoT security and privacy preservation, which is one of the topics of cloud computing big STEM. Since we thought that security in IoT is still a wide topic, we decided to be more specific. Therefore, have creating lightweight Xboxes for IoT. As you can see in the bottom, all of the citations will have the form of citation number, first surname et al., acronym of publication, and year. That being said, let's move on to the problem statement. In systems using Internet of Things, data is obtained by various edge devices, from small sensors and switches to bigger cloud-connected devices like commonly used electronics. The number of these IoT devices and applications is increasing, being deployed in various domains such as smart homes, smart cities, and industrial automation. While IoT makes our lives more convenient, privacy and security vulnerabilities exist. One of the vulnerabilities is the fact that data sent from edge devices can be hijacked easily. This comes as a significant issue because data observed from edge devices is sent to cloud servers in many cases to store and analyze such data for further convenience and welfare. One of the ways to preserve privacy and secure data is to encrypt the data before sending to the cloud servers. However, most of the edge devices are short of computational resources, including hardware area, memory, and energy consumption. For example, if we consider an ATmega 328 microcontroller that is used commonly across IoT projects and applications, it has only 2 kilobytes of SRAM. We will show how small this is in a moment. The point is that conventional encryption algorithms are not suitable in these environments. Because edge devices have small computational resources, we would need lightweight cryptography. However, traditional encryption and lightweight encryption have many steps to encrypt the plain text, which is the input data to be encrypted. For example, AES encryption has several steps to make the ciphertext. Moreover, most of the encryption algorithms are implemented and applied with multiple rounds. Therefore, we focus on the Xbox only, which is the substitution box. This Xbox is fundamental component that provides non-linearity and confusion. Non-linearity is important because common linear operations have easy patterns, thus making the encryption easier to break, while confusion complicates the relation between the input bits and the output bits. Xboxes are implemented as a static lookup table or as a circuit that is substitutes a set of bits to another. If we take a look at AES Xbox, we can see that an 8-bit input is substituted to another 8-bit output. If we were implementing this in an edge device environment, it might not be a good choice. The lookup table has 256 elements, and each element is 8 bits, so the entire size of this Xbox is 256 bytes. Recalling the ATmega 328 microcontroller that has 2 kilobytes of SRAM, a mere component of the entire encryption already consumes 12.5% of the usable runtime memory. Considering the rest of the encryption process, this is clearly not efficient nor lightweight. So our question will be, how can Xboxes be designed with less than 8 bits making the size less than 256 bytes? While we have mentioned only the term lightweight, This is not only about memory or hardware area consumption. There can be low latency, low energy consumption, and even replacing other components of the encryption with Xboxes to optimize the overall performance of the encryption. Also, the implementation can differ by using either hardware-wise or software-wise implementation. We will take a look into the comparison in the next slide. Based on these observations, here we briefly compare 8 different papers regarding Xboxes for lightweight encryption. First, we have a table comparing several papers Xboxes in terms of the number of bits handled by the Xbox and the main purpose of the Xbox design. Because AES's 8-bit Xbox is heavy for edge devices, most of the work selected a 4-bit Xbox design for a good balance between significantly less hardware area occupation and non-linearity performance. The major objective is also about low hardware area or low latency, while Midori has an additional objective of low energy, and optimized client focuses on optimizing the original client by replacing one of the steps with Xboxes. Some paradigm shifts can be seen in the table. These paradigm shifts, which moved from low hardware area to low latency, and from 4-bit Xboxes to higher bit Xboxes, might have been led by this paper from 2012 CHES. The paper concludes that low latency block ciphers should use strong low bit Xboxes or higher bit Xboxes with the condition of low number of ROMs. Here we will go through the pros and cons for each method's Xbox shortly, while Piccolo proposed one of the earliest lightweight ciphers, including the Xbox client, and Prince designed their Xboxes starting from defining the properties the Xbox should hold, providing strong theoretical ground. However, the simple design makes the cipher easy to break. Midori implements low latency and low energy based Xbox, analyzing the latency difference between when multiple Xboxes are deployed sequentially ran in one clock cycle and when less Xboxes are connected sequentially but ran in multiple clock cycles. This circuit depth-wise implementation property lowers the latency, while the involution property saves hardware area at the same time. However, the cipher performance more relies on the number of grounds applied. Since Mantis Xbox follows pretty much the same implementation as Midori's, the pros and cons are shared. The optimization of client replaces the mixed nibble step in the original client with a combination of multiple exclusive ORs and 4-bit Xboxes. However, the use of multiple expensive exclusive ORs increased the use of CPU and memory excessively. Speedy focus on each gate's cost and construct a two-level tree structure consisting the majority of the Xbox with the most efficient gates. Nevertheless, it uses a 6-bit Xbox, which may be heavy for certain edge devices to adapt. Scarf implemented a powerful 5-bit Xbox for randomizing caches and addressing the weakness of Misty, but the use of many exclusive OR gates may increase the latency back. From now on, we will dig into light details of some of the papers for clarity. In Klein, the author defined the properties that the Xbox should hold. The involutive nature that is also seen in Midori show the input should be reproduced after applying the Xbox operation twice. The result of Xbox operation shouldn't be the same as the original input. Both differential occurrence and correlation must be low as well. Differential occurrence or differential attack refers to how often the output difference delta y is similar to delta x, which is difference of two inputs, while correlation measures how strong the Xbox follows a linear relationship between the input and output. The optimization of Klein aims to enhance the diffusion. In other words, the influence of changing a little bit of the input should be significant over the output. This is done by replacing the mix-nibbles step that doesn't use Xboxes at all with a battery of exclusive ORs and Xboxes. Although the memory and RAM consumption decreased conditionally, the execution time has dropped substantially. The authors claims that in this way the ciphertext is more secure to differential attacks and meet-in-the-middle attacks. Meet-in-the-middle attacks is a type of cryptanalysis where the attacker starts encryption with a plain text while starting decryption with a ciphertext at the same time and meet in the middle to see any matching patterns. Meanwhile, as mentioned earlier, Midori compares two different deployments of Xboxes. The round or rolled circuit refers to a sequential connection of Xboxes, while the round-based circuit runs less Xbox operation over multiple rounds. The author found that the round-based implementation saved more energy and thus decreased the latency as well. Beyond the observation, basic operation steps which is gate equivalent are also obtained to optimize the hardware area of the Xboxes as PD did. Thereby, the Xbox for each bit is designed using chip configurations, resulting in less energy consumption compared to Prince, Present, and AES. Scarf modifies Misty to address the weakness of it. One is the high-order differential attack that seeks patterns from the differences of difference across inputs and outputs, which is a high-order attack. Another is the integral attack, where the attacker finds how the output behaves as certain values are summed to the input. Scarf also follows the idea of observing the most efficient gates as PD and Midori. The authors used OAI gates to drop the latency and prevent the Xbox being on the critical path. So far, we have compared encryption methods and provided additional explanations. In this section, we discuss about how the future works on Xboxes might focus on. We assume that the reason latest works started to use slightly higher bit Xboxes is partially relying on the advance of hardware's overall performance. As the hardware capacity and computational performance grows over time, edge devices might be able to expand their ability to higher bits for stronger non-linearity. However, balancing between efficiency and security will be the everlasting task. For the efficiency, comparing and deploying the cheapest logical gates with decent quantity and structure will continue to be considered. On the other hand, enhancing security of future Xboxes will accompany the number of bits as all of the methods considered. Discovering use of Xboxes other than substantial layers as optimized Klein did, studies on mathematical theories to design Xboxes like Klein and Prince, and experiments of new attack. We further anticipate that machine learning will be a new promising way to find the best Xboxes due to the dominant use in various fields, which is somehow similar to Midori and Speedy that implemented a simple algorithm to find the most suitable Xboxes.